Meet Tempest, Europe's bold new fighter jet, born from a powerful tri-nation alliance. The UK, Italy, and Japan are joining forces to ensure Europe isn't sidelined by rising threats. While rivals like China speed ahead, Tempest signals one thing: Europe refuses to follow. It will lead. In 2022, Britain, Italy, and Japan formalized the Global Combat Air Program, GCAP. No one is doing this alone. This joint fighter isn't just about defense. It's a bold commitment to shared strength and shared skies. This isn't theory. It's happening now. With a flight prototype set to test skies by 2027 and full deployment aiming for 2035, Tempest is more than talk. It's progress sprinting toward reality. The Tempest carries twice as much as an F-35 and can fly transoceanic missions without refueling. Europe isn't just staying safe. It's projecting power where it counts. Tempest is more than a machine. It's a thinking partner in the sky. Imagine slipping into the cockpit and your visor becomes a living battlefield map. Every moving target, every heat signature, every radar ping, it's all instantly analyzed by an onboard AI copilot. This AI doesn't just feed you data. It filters the noise, predicts threats before you see them, and even suggests maneuvers that push the limits of human reaction time. It can command drone wingmen, tasking them to scout ahead, jam enemy radars, or strike precise targets, all without the pilot lifting a finger. And because Tempest's architecture is designed to be open, tomorrow's breakthroughs, quantum sensors, hypersonic missiles, even energy weapons, can be plugged in without redesigning the entire aircraft. Why this matters is simple. In a future where China's PLA Air Force is building networks of drones, stealth jets, and satellites, a static design is a dead design. Tempest is built to keep learning, keep adapting, and keep Europe in the fight for decades to come. Tempest is not just about air power, it's about independence. Europe has relied heavily on US aircraft for decades. But what happens if the geopolitical climate shifts and access is restricted? What if, in a conflict with China, America's priority is the Pacific, leaving Europe to guard its own skies? China's growing air dominance isn't a distant threat. It's reshaping military planning now. In a crisis over Taiwan or the South China Sea, European nations could find their naval task groups operating far from home, in contested skies. That means having a fighter with the range, stealth, and brains to survive against next-generation Chinese air defenses. And there's an economic dimension. The GCAP program isn't just military spending. It's a job engine, a technology accelerator, and a way to keep Europe's aerospace industry competitive against the colossal industrial machine China is building.
Electronic warfare gear and cooling equipment needed to mask its heat signature. To reach this level, the company is building an embedded starter generator directly into the engine core instead of relying on an external gearbox and generator. Early tests began in 2014 when a starter generator was fitted inside an existing jet engine, and by 2014, teams had added energy storage and controls to manage power flow. The next steps will introduce more efficient power loops, smarter temperature control, and storage systems tuned to how the fighter actually flies. Because stealth jets often stand out on infrared scans, having the engines double as a cooling system is vital. The gas turbine won't just produce thrust, it will act as a high-temperature power plant and cooler, with smart controls that shift engine output between making thrust, powering onboard electronics, and running heat exchangers to bleed away hotspots. This integrated approach means the Tempest can hide its heat signature more effectively than earlier fighters. By combining a gently bulged rear fuselage with hidden air ducts, internal fuel and weapon bays, and Rolls-Royce's powerful, cleverly managed engines, the Tempest promises to be both hard to detect and hard to stop. As these technologies come together, the new British fighter will push stealth, speed, and onboard power beyond the limits of today's warplanes, setting a high bar for future air combat. Rolls-Royce recognized that modern and future fighter jets would need far more electrical power than what current engines can offer. To meet this challenge, they began work in 2014 on the Embedded Starter Generator program, dubbed E2SG. Traditional jet engines drive their electrical systems by using a gearbox attached to the engine's main shaft, which powers a separate generator. This adds weight, complexity, and points of possible failure. The E2SG approach places an electric starter generator directly inside the engine core. That way, the same unit can spin the engine up for startup and then deliver electricity to every part of the aircraft during normal flight. By doing this, Rolls-Royce aimed to remove the bulky external gearbox, save space, and make engine builds simpler and more reliable. In the first development phase, engineers fitted a starter generator inside a production fighter engine center. By integrating the electric motor generator right onto the engine shaft, they showed that they could start the engine and build power without needing the old gearbox setup. Having fewer moving parts means less maintenance and a lower chance that something will break when crews are far from home. After laying down that foundation, they moved to the second phase in 2017. In this step, they hooked the generator to another section of the turbine and added an energy storage system similar to a small onboard battery. They also wrote new software to control how power moved between the engine, the stored energy, and the aircraft's electronics. This allowed the system to juggle electricity demands during high-power events, like firing up sensors or running cooling for stealth coatings. Every time electricity was needed, the system could draw from both the generator and the storage bank, keeping all systems powered smoothly. The third phase, which kicked off around 2020, has engineers pushing the design even further. Rolls-Royce plans to create two separate electric loops inside the engine to deliver even more power, almost like having a backup generator ready to kick in when needed. They also aim to upgrade the engine's thermal controls by fitting advanced heat exchangers and materials that soak up or release heat in tune with how the engine heats up and cools down during different flight conditions. All of these upgrades will tie into a central power management brain that constantly adjusts engine speed, power output, and heat flow. That way, the engine can feed laser weapons or run dozens of sensors at once without shorting out or overheating, while still keeping weight and size in check. At the same time, Leonardo UK is busy building the electronics that will turn all that power into actionable information in the Tempest fighter. Their work covers four major areas. First, they are creating new radar and electronic warfare gear that uses digital beamforming. This lets the radar look at many targets at once or focus tightly on one, all without slowing down. They are also developing a wideband radio frequency sensor that switches between modes to hunt for different threats, from other jets to ground radar emitters. Second, they plan integrated sensing, where data from radar, infrared cameras, electronic listening devices.
In short, Tempest exists because Europe needs a shield it controls entirely. A jet that answers to no foreign supply chain, no external political will, and can stand toe-to-toe with anything China or any other adversary puts in the air. Tempest evolves with time. Its modular design allows updates, software, sensors, weapons, for decades. This isn't a plane, it's a spine of lifelong evolution. There were doubts. Defense cuts threatened to cancel it, but leaders stood firm. Tempest must fly. It's not just military tech, it's an investment in European independence and innovation. While Tempest takes shape, rivals aren't stopping. The F-47, F/A-XX, J-36, all in flight. Tempest can't just pace, it must lead the race. Tempest isn't just another jet, it's Europe's pledge to defend, innovate, and stand tall. Built together, flying together. Ready for jet number 5? Just say okay to proceed.
Since the Tempest's main mission over the coming decades will be to secure control of the air, it will need both strong firepower and smart, flexible support systems. One of the most talked about ideas is fitting the Tempest with a heavy punch of missiles, perhaps between 6 and 8 of them, housed inside its sleek body to keep its outer shape clean and stealthy. So far, though, no official figures have been released on exactly how many missiles the Tempest will carry. By comparison, in regular service with the Royal Air Force, Today's Eurofighter Typhoon typically loads 4 to 6 long-range, beyond visual range missiles, plus 2 to 4 shorter-range, infrared guided missiles. It also carries an internal 27mm Mauser cannon with about 150 rounds and can be fitted with up to 3 264-gallon fuel tanks for longer flights. Looking ahead, the Tempest is likely to be armed with next-generation weapons that combine the best of British and foreign technology. One of those is the JAM missile, a joint effort between the UK and Japan. This weapon stitches together Mitsubishi Electric's Advanced Active Seeker, essentially the missile's eye, with MBDA's Meteor air-to-air missile motor, which uses a ramjet engine for sustained speed and range. The result should be a fast, agile missile that can home in on enemy aircraft over great distances. Beyond air-to-air combat, the Tempest might also carry new kinds of cruise missiles, aimed at taking out ships or other high-value targets on the ground. These would eventually replace the Storm Shadow, Scalp family of air-launched cruise missiles currently used by Britain and France. Modern cruise missiles can fly low to the sea surface or terrain, avoiding radar detection, and strike from hundreds of miles away. Perfect for first strike missions or hitting targets that are heavily defended. But perhaps the most futuristic idea is that of loyal wingman drones flying alongside the Tempest. In small groups or swarms, these unmanned aircraft could undertake dangerous tasks that would be too risky for a pilot. They might scout ahead, jam enemy radar, launch their own missiles, or even draw enemy fire, protecting the human-piloted jet. With every new generation of fighter jets becoming more complex and costly, adding cheaper, expendable drones into the mix could give commanders more options while reducing risk to personnel. To speed up development and share the burden of research and production, the UK government has brought in a host of partners from around the world. At the Farnborough Virtual Air Show in 2020, then Defense Secretary Ben Wallace announced that 7 more companies would join the existing core team, now called the Tempest Consortium. These newcomers included GE UK, a joint venture of General Electric and UK interests, GKN, Collins Aerospace, Martin Baker, Kinetic, specialists in weapon systems, Spirit Aerosystems, airframe builders, and Thales UK, sensors and electronics. Together, this expanded group is tasked with designing, testing, and proving more than 60 separate technology ideas for the future fighter. That work ranges from new engine components and stealth-friendly airframes to advanced cockpit displays and AI-driven control systems. Each company brings a different piece of the puzzle, and by sharing the load, the UK hopes to keep costs manageable and get cutting-edge capabilities into service more quickly. All of these developments, advanced missiles, partner-built drones, cutting-edge cruise weapons, and a strong multinational team, are being aimed at one clear goal: making sure the Tempest and its networked wingmen can dominate the skies well into the 2030s and beyond. By blending proven British know-how with fresh ideas and international collaboration, the UK wants to field a fighter force that is stealthy, powerful, and smart enough to meet whatever challenges the future might bring. In December 2020, the United Kingdom formalized its Tempest partnership with Italy and Sweden by signing a memorandum of understanding that outlined each nation's contributions in technology, funding, and expertise. Not long afterwards, Japan joined the effort, committing to co-develop an engine test bed and a demonstration radar system, codenamed Jaguar, specifically tailored for a 6th-generation fighter. The engine test bed will allow engineers to simulate extreme conditions on the ground, ensuring the power plant meets the demands of a stealthy, high-speed aircraft. Jaguar aims to prove advanced, power-efficient radar modes that can swiftly switch between searching, tracking, and electronic warfare before being integrated into the flight-ready Tempest. Developing a cutting-edge fighter is a costly endeavor. From initial design through to full-scale production, the UK expects to spend more than $8.3 billion on the Tempest program. By comparison, the US Air Force's estimate to research, develop, and manufacture its new B-21 Raider stealth bomber stands at roughly $29.5 billion, about 3 times the projected cost of Britain's next-generation jet. Despite this hefty price tag, British defense officials have emphasized speed and